Good afternoon, the top management of Lajaku. Our group is assigned to analyze if there is any problem encountered, such as fluctuation in weight and inconsistent hardness in the manufacturing operation of Lajaku tablet C. Our group is led by Go Yongzhen, and our group members include Gary Tam Chi Kin, Soren Chai, Kenneth Eli Wei, Lee Ka Hong, Oi Ao Song, Yu Chaini, Karishman, Amira, and me, Lo Ka Han. Now, one of our group members, Soren Chai, and I will be presenting our analysis on the first part of the assignment, which is to describe and summarize the sample data of Lajaku tablet C. Okay, first of all, let's look at the weight of the tablets. We have selected 200 tablets randomly from 3 different working shifts, and we group the tablets into different weights intervals, with each of the intervals have a range of 10 mg. Then from the data we obtain, we plot the data into a bar chart, and you can see the shape of the bar chart is in a bell shape. And from the 200 tablets that we selected, the minimum weight is 317.82 mg, the maximum weight is 393.33 mg, the mean weight is 349.1543 mg, the median is 348.995 mg, the standard deviation is 13.2327993 mg, and the variance is 175.106974 mg. Then we also plot a scatter plot of the weight of the tablets, and you can see all of the tablets are weighed between 300 to 400 mg. So that's all from me. Next, I will pass to my friend Soren Chai. Thank you.
Hi, my name is Soren Chai. So from the 200 samples taken, we can summarize all the relative density in percentage into the table and also the graph. So from the graph, we can clearly see that from the range of 86 to 88% of relative density contain the most pure Lajaku C, which is 80 pills. And then for the 82% to 84% contain the least pills, which is only 5. And then from the 200 samples taken, the minimum relative density is 82.8% found, and then the maximum is 93.3. The mean is 88.14%, and then the median is 87.9. The standard deviation is 1.92, and the variance is 3.7. So now we're going to the tensile strength of the pure Lajaku C. So from the 200 samples taken, we summarize all the tensile strength in megapascal into the 6 category and summarize it into the table form and also the graphic form. The most pure content is in the range of 7.7 to 7.2 megapascal, which is 82 pills content. And then the least is from 7.6 megapascal to 7.8 megapascal. And then from the 200 samples taken, the minimum tensile strength is for pure Lajaku C is 6.6 megapascal. And then the maximum tensile strength in these 200 samples is 7.7. The mean is 7.152, and then the median is 7.1. The standard deviation is 0.19. The variance is 0.038. So now we're going to the shift to produce this pure Lajaku C. So from the 200 samples taken, we summarize all the 200 samples pure into the table and also the graphic form. So we can find that from these 200 samples, most of the pure Lajaku C is produced in evening, which is 71 from the 200 pills produced. And then the second most is in the night shift, which is 68 pills produced in this shift. And for the least is in morning shift, which is contain 61 out of 200 pills produced. So this.
My name is Gary Tam Chi Kin.
My name is Kenneth Eli Wei.
So for the step 1 is the arrangement of the data. Since the weight of the weight data in the appendix C is randomly organized, and we need to arrange in an order to more simple calculation for the later use. So we use the function of sort by in the Excel to arrange the data in the ascending order for a simpler calculation. And then the data is categorized into the intervals such as below, such as x smaller than 320, 320 to 330, and until 380. And coming to the step 2.
So for step 2 is the null hypothesis statement. There are two. One is null hypothesis statement, which states that the weight of standard tablet produced by manufacturer is normally distributed with 350 milligram and a standard deviation of 40 milligram. And the alternative hypothesis, which is the other way around, states that it is not normally distributed. And for step 3.
So coming to the step 3, which is the tabulation of the data. The range can be converted into the probability by using the formula x minus 350 over 14. So you can see the table below. We also have the frequency data, which we obtain by using the count function from the Excel for the specific range. So to verify this table whether it is in a proper or correct method, we can use the summation to check the values. So the summation for the frequency should shown 200. So through the calculation for the summation of all frequency that we obtain, we found out that the summation is equal to 200. And then to check whether the probability is correct, we also do the summation for the each probability, and it also shows up that the value is equals to 1. So it is shown that this table is correctly verified and okay to use.
So the next step is test statistics. After the tabulation of data, the frequency is actually the observed value, and how to get the expected value is actually using the total observed value times the probability. So let's say for example 200 times 0.0166 is equal to 3.32. And after we get the observed value and the expected value, we can calculate the chi-square value, which is the chi-square test. And then the chi-square value is actually observed value minus expected value squared divided by expected value, and sum it up, we can get the chi-square test, which is at first 3.6666. And since that there are data which is less than 5, if you can see from the expected value 3.32, we need to merge the data. So after we merge the data, we get expected value of 15.28 for both top and bottom side. And lastly, we get the new chi-square test is 3.5240. Next.
For the step 6, we need to identify the x value from the statistical table. So our group assumed that the significant level alpha, which is 0.05, and the v, which is we can obtain from the number of range that we have. We have 8 ranges, and then we will minus 1, we will have 7. So according to the chi-square statistical table, we obtain the value of x squared 0.057, which is equal to 14.0671.
So the next step is the rejection rule region. As we can see from this graph, the rejection rule region, the rejection H null region is actually more than 14.0617. So we can only reject H null if chi-square test is more than 14.0617. But throughout our test, we get the chi-square test is 3.5240, which eventually comes to that peak.
For the conclusion part, since the chi-square test value was in the accepted region, and thus we conclude that we failed to reject the hash knot, and the weight of the standard tablet was normally distributed with the mean of 350 and the standard deviation of 14. So we also show that there is a significant evidence that the larger Laku tablet C, regardless of shifts, does follow this distribution. Thank you. We will pass on to question C.
Thank you.
Okay, first of all, the first thing we have to do is sort the data. Okay, we took the weight with the data of the weight, okay, and divided by 3 shifters. Okay, that is evening shift, morning and night. Okay, okay, then we put the data in a column, okay, according to the shift. That means morning data is inserted in morning column, evening data is inserted in evening column, and night data is inserted in night column. Okay, then okay, in this case we are using ANOVA, okay, and we're using ANOVA, okay, and in this case, okay, we will summarize the each shift. Okay, for the morning shift they have some average and variance, and also for evening and night, okay, they are shown in this data. Okay, then we are using ANOVA. When we are using ANOVA, we will find the sum of square SS, df is degree of freedom, ms is mean of square, and f is f test value. Okay, in this case, okay, we can identify whether the HO is acceptable or rejected. Okay, in this case, if f critical is larger than f test value, okay, the HO is accepted. Okay, and also in case the p value is bigger than the alpha value, let's say 0.8, p value is 0.8 and larger than alpha value 0.05, okay, the HO is accepted. Okay, and the same case goes to alpha 0.1. Okay, the f critical is larger than f, and p value is larger than alpha. So that's all. Thank you from us.
Next, we'll be reporting regarding the regression of the relationship between tensile strength and relative density. Studies have shown that the relative density and tensile strength have a relationship of tensile strength depends on relative density. So this is the summary output that we have produced for the regression that we have created. So first, we'll take a look on the regression statistics. We can directly obtain the value of coefficient relationship between tensile strength and relative density, which is the value of multiple r is 0.86, or is equal to the square root of r squared, the square root of 0.74.
Next, we have the ANOVA table. First, we look at the degree of freedom. The degree of freedom of regression from data is 1, and for residual is 198. Next, we have the sum of squares, which is 5.56 for the regression and 1.94 for the residual. Next, we have the mean square, which is SS divided by the degree of freedom, which is 5.56 for the regression and 0.0097 for the residual. Next, we have the F value, which is the mean square value of regression divided by the residual value, which is 567.
Now we have to make a decision on the significance of regression, which is by comparing the significant F with the chosen significant level alpha. In this case, is 5%. So the significant F value is 4.6 times by 10 to the power negative 6, and the alpha we have chosen is 0.05. So we can clearly see that the significant F value is way much more lower than the alpha value, which indicates that we can reject H naught in this case, and we can conclude that this value provide a very strong evidence on the existence of linearity between tensile strength and relative density.
Next, we have the line flip plot of the tensile strength against the relative density. And the equation that we can get from the line is y equals to negative 0.51 plus 0.08692x.
This equation is produced to determine the prediction of tensile strength. So in this case, a batch of cluster of the tablets have been found out having a low relative density of 68%, 74.3, and 80.1% respectively. So in this case, we will be substituting the x value with the relative density. So when the relative density is 68%, the predicted tensile strength for it is 5.40 megapascal. And when the relative density is 74.3%, the predicted tensile strength is 5.95 megapascal. And lastly, when the relative density is 80.1%, the predicted value is 6.45 megapascal. Next, we will be moving to the summarize of the whole reports.
Hello, my name is Gary Tamzikin.
And I'm Boyong Zheng.
Now we will be presenting the summary for the report of the tablet C. Next. So for the question B, the summaries is that we have proof that the chi-square test is actually smaller than the chi-square value that we obtained from the statistical table. Thus, the summary is that we're able to show that we fail to reject the H0, which is the weight of the standard tablets produced by the manufacturer is normally distributed with 350 milligrams with the standard deviation of 14 milligram. And next.
Okay, so next for the question Q6, the question requirement is whether there's any significant difference between the tablet weights in milligrams from the different shifts. So we have proved that by using different value of alpha using ANOVA table, which is 0.05 and 0.10 respectively, it shows that the both alpha value shows that the F critical value is bigger than F, therefore the H node is accepted. Then for the question QD, we have to determine the prediction of tensile strength by using the relative density that is given, which is 68%, 74.3%, and 80.1% respectively. So there's we have plot a graph for tensile strength against relative density, where this is the scatter diagram that we have plotted, and we obtain an equation from the diagram, which is y is equal to negative 0.51 plus by 0.086x. So we'll be substituting the relative density value into the x, and we will get the prediction of the tensile strength. When the relative density is 68%, our tensile strength is 5.40 megapascal, and when the relative density is 74.3%, our predicted tensile strength is 5.95. And lastly, when our relative density is 80.1%, our predicted tensile strength is 6.45 megapascal.
So coming to the end for this assignment, I would really like to give a big thank you to our Dr. Fauzee, and then our group member, which is Goh Young Zhen, Gary Tam Si Kin, Soren Tsai, Lee Ka Hong, Kenneth E. Lee Wei, Lo Ka Hang, Wei Yao Song, Yu Chani, Krishman, and Amira will say a very thank you for Doctor to teaching us for this semester. Thank you, Doctor.
Thank you, Doctor.